Okay, we're going to finish chapter 5.3, um, implementing, before we did the multiplication rule for independent events. Now we're going to do a problem, a common probability situation that's called at least probabilities. The phrase at least means greater than or equal to. And to do this, we're going to kind of use what's called the complement, which in the previous section is to kind of solve this. And so, let's look at this example. The probability that a randomly selected female aged 60 years will survive the year is 0.99186. That's pretty good for a 6-year-old. That means they have a 99% chance of surviving the year. What is the probability that at least one of 500 randomly selected, what's the probability that there's the at least, one of 500 randomly selected 60-year-old females will die during the year? That at least one of those. Well, we know it's a 99.186% chance that you'll survive, at least that one of them will survive. But what's the probability that at least one will not survive the year? They're not going to make it. So in this case here, really what we're going to do is probability at least one dies is going to be, we're going to use a complement rule to do this, is the 1 minus the probability that none die. So keep in mind that the term at least means greater than or equal to 1. So what's the probability that at least one dies means, what's the probability that one dies or two dies or three or four? And so this is really a long or situation. I would look at the book and read that and to finish kind of this example, just so you can see the full notation. I'll show you what that looks like from the book situation. There's a different example in the book to look at. Here it is here. Let's see if I can get, I think it's the next page. Oh, next page. There it is, at least one right here. And so what we're looking at, I would read that if you're not sure, but you can see the notation. Otherwise, if we solve a direct method, it would be like probably 1 or 2 or 3 or 4. So you could read this example. But that's too long. So we end up doing is we end up using this kind of trick right here, that the probability at least one dies is equal to 1 minus the probability that none die. And so I would take a look at that. And so then we can calculate what's the probability that none of them die. We can do that calculation. We did that. We basically did that up here. What's the probability that 24 will survive or none die? So this turns out to be 1 minus the probability that none die is 0.99186 raised to the power of 500. And so we need to do something like that to get the answer. So what we're going to do is we're going to raise 0.99186, if I can get it there. Clear that. 0.99186 raised to the power of 500, and you get 0.01, 3 decimals, 0.017. So this turns out to be 1 minus 0.017. And when you subtract that, you end up with 0.983. So there's a 98% chance that at least one of those people out of the 500 will pass. And so that's the example. You want to practice that. There's not a lot of those on the homework, but you want to practice a couple of at least problems because you use this number trick there. Summary here. These are just some of the rules that we just went over right now. So this kind of consolidates all the ideas for rules of probability in this section here that we have. So you can take a look at that. Okay, and also, like I said, has the OR problems. You don't have to memorize this, know how to use it because it's in our formula sheet.